Morning, all. Welcome to this edition. Welcome to this edition. I'm glad to be part of this edition this morning. Remember, this is what we have decided to do to help a lot of young people out there, especially to improve, to help them improve on their skills and also bring to their doorstep through the help of the internet, their curriculum. So today we are going to be looking at introduction to computer science. Introduction to computer science. Uh, we're going to be looking at what a computer is, not just what a computer is. We're going to be looking at computer science. What is computer science? What is a computer? And we're also going to look at the components of a computer system. Aside looking at the components, we're also going to try to juxtapose these components. We'll try to take a look at the components inside the computer. We'll be looking at the computer system as a whole. When I mean the computer system, the major parts of the computer that makes the computer a workable tool. And then we're going to be looking at the central processing unit, which is just a part of the computer, which is always known as the brain box of the computer. And we're going to be looking inside of it. We're going to talk a little about computer networking, and then we'll now move forward. Okay, so what is computer science? I am sure most people who are studying computer science would, at their first year, be faced with some science course, of course, like you'll be coming across chemistry, physics, and biology, and all the rest, and then you do a little introduction to computer. So this particular course is the introduction to computer science you do at your entry level in the higher institution. So if you're a polytechnic student or you're a university student and you are watching me, just know that this is a dive into computer science. So computer science is that study of computers. So it is important to know what the computer is. So what is a computer? A computer is a machine. A machine is a device, or a machine is a system that helps you carry out your tasks. Most of the time, you must have heard that a computer is an electronic machine that accepts data, gives you the results, just like what you're seeing on the screen. You must have heard that the computer can help you do so many things. Of course, you have been exposed to the computer. Your mobile phone is a kind of computer. I'm sure most young people today make use of the mobile phone. You make use of your tablets, you make use of your laptop, your desktops. All these are part of the computer. The WhatsApp, the Facebook, and all the software applications we have loaded on our computer would not be workable if the hardware, if the full components of the computer system is not put together to work. So what is computer? A computer is an electronic machine. Take note, it's electronic because the circuitry that makes up the computer is electronic in nature, because you can't talk about the computer and putting electrical electronics aside, because every part of a computer, when you open your computer set or you open your mobile phone, you are going to find digital circuits and you're going to find electronic system. It's an electronic system. So a computer is an electronic system or an electronic machine that takes up data from the user and then try to fine tune this data into information. Tries to fine tune this data into information. Information varies, like you can see on your WhatsApp. You're getting you're getting a reply. The reply you're getting after sending a message is a kind of information. To some other people in a business environment, the information they'll be looking at is pictorial informations or pictorial results from a process data. Maybe you have a graph. You're trying to do business analysis. You're analyzing, say, demand and supply of your business. Imagine the type of information you will be getting from those kind of data if they were to be raw data. You are going to be looking at charts, graphs, and all of that. So that is about the computer. So let's look at the computer system. What is a computer system? When we talk about a computer system, we are talking about the various parts of the computer, the various parts of a computer that makes it workable. Not just the central processing unit, which is the brain part of the computer. I mean, all the components attached to the computer that makes it usable for us. And so that's why you hear the word system. Anytime you hear the word system, a system is a collection. A system is a collection of other subsystems. So when you talk of the computer system itself, if it's a system, it means there must be some other subsystems. These subsystems are usually called components. So all the components that makes the computer workable, if put together, it is a system. And if we look at it individually, they are components. So component 1 plus component 2 plus component 3, device 1, device 2, device 3, all forms a computer system. So from your screen, you are looking at what a computer system is. You are looking at a desktop computer. You're looking at a desktop computer, and that desktop computer you're looking at has a printer, has a monitor connected, you have speakers, CPUs, keyboard, mouse. So now every part, every component of the computer, every component of the computer has it could be classified into two major parts. It's actually you classify them into the software and the hardware. The software part of a computer is the part of the computer you won't be able to feel or touch, but it is there running as instructions given to the computer. Why the hardware part of the computer are the part of the computer that can be felt, like the speakers and so. Also, the computer is also classified, the computer components are also classified as input or output components. For example, your monitor is an output component. Why is your monitor an output component? The last image you saw there displayed was a monitor. You saw that the monitor is an output component because information is being projected out from the monitor to the user. You don't send in information through the monitor, rather you retrieve information from the monitor. So the monitor is an output device. How about your speakers? The speakers connected to your system, your earphones. In the case, your earphones are input stroke output device because your earphones have some little microphone attached to them. So with the help of your microphone, it's now an input device while the speakers are output device. So what about a scanner? Is a scanner an input device or an output device? A scanner is an input device because what the scanner does is it scans the information on your documents, your hard copy documents. It scans it and then gives you the results in soft copy formats. So the scanner itself, when we look at it, is an input device. Of course, you know the keyboard is the most used input device. On your phone, you use your keyboard, and this keyboard is an input device. So that is all about computer system, the computer system. The computer system is different from the computer. So now let's look at uh, uh, individual components of the computer now. We want to look at the individual components of the computer. Individual components of the computer. You see that we made mention of the central processing unit. The central processing unit is one part of the computer that it's called the brain box of the computer. And I will tell you why it's called the brain box of the computer. It's usually short form, the abbreviation for it is called CPU. It's called the inner working brain or the brain of the computer because that is where you have a chip called the central processing unit. The central processing unit. That is where you have a chip called the central processing unit. What does the central processing unit do? The central processing unit, you can see from your screen, is the working of the computer that has the processor, it has the board, it has these circuitries work together to accept data from the user and give the right output to the user. For example, you can see that if we break the CPU into parts, we're going to be getting what looks like a VGA card. A VGA card is one part of the CPU. What does the VGA card do? The VGA card is responsible for transmitting the signal from the board into series of bits that can be translated to pixels to your monitor screen. That is, everything you see on your monitor screen is a pixel. And in computer science, we say a pixel is short form for picture elements. So pixel, picture elements, pixel, picture elements. So it means that during rasterization, there's something called rasterization. When we look at graphic design in advanced courses, we're going to explain this, but just know that the inner working of this CPU has also what is called the processor. Most times you must have heard that this processor runs on a 32-bit bus architecture, or this processor runs on both 32 and 64 bits. You must have had something like your processor is an Intel processor or it's an AMD processor. Of course, the AMD processor, which is the advanced micro device processors, are usually not advised to be used in countries like West Africa where it's very hot. But when you are in a country that experiences cold weather, like in the UK, in the Scotland, or up there in the West, you could use AMD because AMD generates a lot of heat. Right here in West Africa, one of the processors that we enjoy using so much here for desktops or laptop computers is the Intel processors, and the Intel processors are known to be rugged during hot seasons. So when you look at that picture, you must have been able to see the various parts of the computer and how they work. I remember I only made mention of the VGA. There are still other parts there in the computer aside that a chief part of the CPU is the motherboard. The motherboard is one of the most electronic sophisticated device or components of a CPU. The motherboard has ICs, capacitors, and slots. These slots are also made for add-on. For example, the RAM slots in your motherboard. The RAM slot in your motherboard is used to accept RAM. Of course, as a computer science student starting for the first time, you may ask yourself what a RAM is. The RAM is the type of memory that resides in the computer board or in the motherboard, which I've told you, and it's known as random access memory. Random access memory are volatile memory. Why do I say they are volatile? They are volatile because immediately power supply goes out from your computer, the RAM can no longer retain any information. So most information saved on your RAM are operating information. What I mean by operating information is the information required for your computer to operate. So when your computer is not operating, the RAM loses or temporarily releases all those information. So the RAM is different from the ROM. Just like many of us use Android phones and iPhones today, there is a capacity for these phones, and these are storage capacity. Every computer has a storage capacity. So for your Android, most time you find RAM, ROM, and an external storage. RAM, ROM, external storage. The ROM is an internal storage. The ROM is not volatile like the RAM. The RAM is volatile because anything saved on the RAM is what is required for the operation of the computer at that point in time. Immediately the computer stops operating, the RAM releases this information, so it is volatile. Some RAMs are in sizes. You have RAMs of 2 gigs, 4 gigs, 8 gigs, 16 gigs, and so on. The RAM of the first laptop I used was 2 gig before I upgraded to a 4 gigabyte RAM, and now I use a system that has an 8 gigabyte RAM. The larger the size of your RAM is the faster your system. If you have a larger RAM size, then be rest assured that you are going to have a faster system. So one of the indices for checking a fast system or for checking up a system that will run fast is the RAM, the RAM size. RAM size is one of the, so if you are buying a computer system today, aside checking the processor, whether it's an Intel processor, and another thing to check for is the RAM size. I've been trying to explain there are also some fans you find in your desktops. Your desktop and your laptop use this fan. Why do they use this fan? They use this fan so that they can cool off the air coming off from the system. You also have, remember I talked about your external storage. External storage are a kind of storage where you can load off your information, whether your system is running or operational or not at that point in time. Your external storage are capable of holding your information. For example, for your mobile phone, I'm sure you must have seen your little SD cards. SD cards range from 8 gig, 16 gig, 32 gig, 64, and so on. For our computers, the latest technology in the external storage devices are SSD. SSD. So when we get to operating systems and we are talking about storage, we're going to dive into your conventional. We're going to describe the difference between your conventional hard drive and the SSD drive. Remember, one of the advances in computer science is the introduction of microtechnology. Microtechnology is a technology that has to do with building systems, sophisticated systems, considering a portable and a smaller size. So microtechnology would always consider the size of the components. So that is what has led to moving from large resistor circuitries we used to have in the early 50s to advancement of computers that we now have today, where you have so much powerful a computer can be. Like you have your iPhone 13 and 14. You see how sophisticated these systems can be. They can even be as more powerful than twice or three times your personal computers. This is because of the advent of microtechnology. Microtechnology. Like I said, microtechnology is a technology that involves building sophisticated computer systems, but considering a small size, portability. Okay, now it's also important we look at how computer interacts. How do computer interacts? What is computer networking? Computer interacts with networks, and it is important for computer to interact. Why do computer needs to interact with other computers? Why do you have your computer interact? What's the need for interaction between one computer and the other? The main reason for interaction or networking between a computer and the other is solely for sharing resources. Solely for sharing. Let me put it very well. Solely for sharing. What can you share when you have a network? You can share computing power. For example, if you have if you have 10 persons doing a job, you know of course the job must have been divided into 10 places, and you would be able to have maximum throughput. What I mean by maximum throughput, what I mean by throughput is the amount of job each person is able to deliver per time. So the use of networking enables different computer devices share information across the network. It also helps them share computing power. When you have a network and your network configuration is you have a client architecture, because in computer science we would always be talking about architecture. Architectures are always showing you the design of the operation of a computer system. So when you get to an establishment or a business or where a network is set up, you should be able to look at the architecture of the system and see what kind of architecture are they running on this computing environment. Sometimes the architecture could be say a client server architecture or a client architecture, or a pair to pair, which is also the client, a pair to pair where each person holds a likely amount of information the other person holds. So I'm talking about networking. Computer networks are interconnections between computers. So when you interconnect your computers, you are setting up a computer network. Just like you're going to see shortly from the screen, what a computer network looks like. A computer network requires computing devices like router, like switch, like bridges, like hubs. These are what makes computer connect. And computer connects using wireless connection or non-wireless connection. These are modes of communication or modes of networking in computer science. We talk about wireless networking or wired networking. When we use wireless networking, we begin to talk about access points. Most of us we have Android phones. I like to make reference to our Android phones because it will make us as beginners understand what what wireless networking also means. Whenever you connect, there are two modes of networking are found on an Android phone. For example, whenever you tether your hotspot from one phone to provide internet connection to another phone, you are using your hotspot as an access point. So an access point is a device, a computer device or a networking device that is used to provide network to other computers. So other computers connect to an access point wirelessly, either wired or wirelessly. So your hotspot is a kind of access point when you use it to share a wireless network to other computers. How about when you do what is called USB tethering? Most of us have put our wireless and we put our USB cords on our systems and we connect them to maybe a desktop or a laptop for charging. The first thing the computer asks you is it gives you a prompt and says, do you intend to charge your laptop using this cable connection, or you want to tether you want to do what is called a USB tethering. USB tethering means you are passing information, you are passing resources of your mobile phone to the computer or to the PC you are connected to. So when you say you are using USB tethering, it means you can tether your internet from your mobile phone to your laptop or even to your printer, as the case may be. So a computing environment that is networked will allow users to share resources, to share computing power efficiently. So one of the main reasons of setting a computer network is to share resources, is to share computing abilities. So if I have a computer that can render graphics very well, and I have another computer that has a large volume of storage, external storage, I may decide to put both of them on a network so that the computer that has, say, an added graphics card or graphic memory should be able to handle graphics, while the computer that has the largest storage um, share, uh, should be able to handle the area of data in terms of storing data. So that is on computer network. It's also important we talk about the working of the computer. Aside the computer networks, remember I said there are two components, classifications of the computer, the hardware part and the software part. Another people or another text will tell you it's the hardware, the software, and the humanware. The humanware is the interaction that brings the software and the hardware together. But now let's look at what is a software. A software is a well prepared instruction, well engineered instruction. Now, mark me using the word engineered because software are actually engineered. Whenever we talk about software, we talk about engineering because they have to be packaged, well documented, well written. A lot of considerations have to be made whenever you are making a software. So software are not just instructions, but rather software are engineered. They are built following series of laid down principles, engineering principles. As we move into the depth of computer science, we are going to look at software development life cycles, and then we're going to look at paradigms of software development, like how software can evolve from, uh, from say, software can evolve from models into the main concept, from concept into the main system. So these are evolutions of software, and they are all in software engineering. So that is that for software. The software is the part of the computer you cannot see. The computer takes instruction given in the software. So the software is a compendium of instructions built for the computer to follow. Now, it is just synonymous to you having, say, okay, your normal system, your normal radio system, you have to give your radio system some command so that they can do what you want them to do. For example, you have to tune in your radio system manually into a frequency where you have to pick a signal so that you can hear people on the radio station. Those commands you're giving to your radio set to give you the required radio station you want is the instruction. But in the computer, in computer science, these instructions are not just tuning, putting on, they are given to the computer electronically. So when I mean electronically, they are passed into the computer by written instructions on the computer. Now, what is the hardware? The hardware is the part of the computer that is to be instructed. Imagine your computer is the CPU. I'm looking at the CPU holistically now, and you're looking at the central processing units of the system units. The central processing unit. I'm not looking at the central processing unit as the system unit box itself, but I'm looking at the central processing unit as the internal circuitry of the motherboard. Now, you need to give instruction to your central processing unit, and you need to move, say you need to copy a data from a register. A register is a kind of memory in your CPU. Now, in your processor, in your arithmetic, in your processor. Now, you need to what this means is this. Let me get this right to you. You want to move, say, from a register AX to another register BAX, or you're moving, say, from a cluster memory to another memory. You need to pass these instructions to the computer. You cannot speak these instructions verbally. You need to give the computer a written instruction. And this written instruction must be coded and fed into the computer so that the hardware, which is the physical memory, can perform this instruction. How do they get to do this? There is an interfacing in your computer system. There is an interfacing in your computer system aside that this interfacing is called the application, the utility software. And one of the utility software system, the operating system you have is your system software. And what the operating system does is it serves as an intermediary between the software layer and the hardware layer. It serves as an intermediary between the software layer and the hardware layer. Imagine you are writing instructions. Who receives the instructions and give the command to the hardware, which is the physical part of the computer you can see? That part of the computer is called a system software. And one of the type of system software we have is the operating system. The operating system is one of the largest software parts of a computer system because it's in the operating system you have the loads of kernel where each of the hardware components communicates. When we look at advanced courses in operating system, we will see a lot of complexities that come in operating system, as one of the responsibilities of the operating system is to schedule tasks because the computer carries tasks. It is the duty of the operating system to say this task goes first. We are going to look at cycles of the operating system. How does the operating system carry out cycles? We are going to look at fetch cycles, we are going to look at execute cycles, we are going to look at read and write cycles, and we're going to look at how the computer works on all of this. It is important at this point to tell us that the computer works on set of instructions, and this set of instructions, well ordered, are called algorithms. So from time to time, you'll be hearing us talk about algorithms. There are series of steps taken by the computer to accomplish a task. Whenever the computer wants to accomplish a task, be it to shut down or to boot or to write to a memory or to copy from one memory location to the other, the computer must go through what is called an algorithm. So, an algorithm is a series or sequence of instructions given to the computer to follow to perform a task. For example, you know that the first thing you must do before you can go out in the morning is you must clean up. You must wake up from your bed, possibly say a prayer. After saying a prayer, you brush your teeth. After brushing your teeth, you go to the bedroom, you have your bath. And after having your bath, you put on your clothes. After putting your clothes, you make sure your shoes are in order, then you step out. How orderly, you see how orderly these instructions are. In computer science, we call these orderly instructions or this sequence of instructions, we call them algorithms. Algorithms. Don't worry if you're not able to pronounce it at the beginning when you are learning computer science. Just like most times, I've been seeing a lot of people call it algorithms, gradings, and all of that. Don't worry, it's called algorithms, or algorithms, whichever one you want to call. If you want to call them, but it's algorithms, algorithms. So these are sequence of steps given to the computer to follow to carry out a particular tax. We also look at further introductory course. We are going to look at flowcharts, algorithms, and pseudocode. Anytime you want to write a computer program, there is therefore need to bring out or to conceptualize what task you want to achieve into what is called a pseudocode. Pseudo means false, meaning that your pseudocode is not the actual language the computer understands, but it is written. A pseudocode is a way of representing your algorithm, the sequence of steps to accomplishing that task. For example, I want to draw a circle. I want the computer to draw a circle for me. The first thing I need to check is I need to check points before, because if you want to draw a circle, you must begin from a point. And then when you begin from a point, you begin to move through a distance and make sure you are covering a radius. You must have a center point, and you make sure that every distance you take, every from the point you start drawing your line to give you a circle, you must make sure that the radius from that point to the center, a center point R that you choose, you make sure that you have an equal radius moving around so that you can have a perfect circle. So you have a radius, for example, you are moving from this point to this point, and then you see that at every point you'll be making reference to the radius. So it is important when you are writing such kind of code, you can tell the computer, say, um, let r, let radius be equal to a variable r, and you can say let points p, or let starting points be equal to p. And so from here you begin to take the next step of instruction to tell the computer on how to draw the circle. When we come to computer graphics, when we come to design and programming of computer graphics, we are going to look at drawing various shapes and how informations are presented on the computer. Now, I've been able to talk about the hardware and the software of a computer. Um, it's important to understand that the interacting layer between the software and the hardware is the system software. The system software itself, an example or a core part of the system software is the operating system. If you are using a PC, the latest Windows operating system now is Windows 11. Windows 11. Younger generations may not understand the generation of Windows and the evolution that has happened between in the Windows operating system. When it was MS DOS, from MS DOS, Vista, Windows, Vista XP, XP Vista, 7, 7 Home, Professional, Windows 8. Windows 8, Windows 8.1, and now to Windows 10, and now we have a better stable operating system, which is called the Windows 11. The Windows 11 supports a lot of IoT features. When we get into advanced course in computer science, we're going to show you how Windows 11 does IoT or has the platform for doing IoT. And maybe we look at some example projects, how we can configure our refrigerators at home, and how we can configure, how we can turn off the lights. For example, I can decide to turn off the lights of this house from my mobile phone when we start doing Internet of Things using some digital circuitry and with the help of internet. So we're here to talk about the application software because there are three types of software. We talked about the application software, the system software, and the utility software. The application software are those softwares we have that interact. This software interact with uh, our operating system. Application software interact with our operating system. An example of our application software, you have Microsoft, you have Gmail, that's where you have your Gmail, that's where you have your Facebook, that's where you have your Chrome, that's where you have your camera, just like you can see on the screen. You have your Instagram, you have you have all kinds of apps, your Safari browser, all of them are interacting with the operating system. So it is the operating system remains the interacting part between the software and the hardware. Uh, these are just introduction to computer science and the various components that we'll be hearing about in computer science, computer networking, and all of that. So it's important we look at also the summary notes, how we began this course. We began this course by going to introduction to computer science. We've looked at why computer science. Why do you need to study computer science? You need to study computer science so that you can the world is going global and there's need for interaction between various computing platforms from your mobile phone to your iPads to your laptops and business intelligence. A lot of analysis are done using business intelligence. You analyze data and you can discover patterns from data when you understand some important topics like knowledge discovery and artificial intelligence in computer science. So, computer science is the science that deals with the study of the computer and its application. The computer and its application. The study of the computer itself and its application to your environment. We looked at the building blocks of computer science, the computer itself, the networks, and we looked at how the computer interacts with each other. We looked at input and output devices. We looked at software and hardware. We looked at application software, system software. We also looked at utility software, softwares that are made specifically for a particular kind of task. We also looked at how the software interacts with the hardware with the help of um, the um, operating system, which is the system software. So, in our next class, we're going to be taking into a better dive into computer science. So, thank you very much. Thank you very much for watching this video. Invite your friends who are into computer science so that they can take this ample opportunity to learn the curriculum of computer science for a degree in the university. If you are in the university or in a polytechnic and your field of study is computer science, this is the right channel for you where you can study, where you can get to know a lot about computer science. Not just knowing about computer science, you'll be able to